this is teacher Isaac here, who is going to take you through trigonometry 1 and trigonometry 2. But our main focus is going to be on angle of elevation and angle of depression, and then also application of sine rule and cosine rule. We want to thank you so much for watching our videos. Please don't forget to like, share and subscribe if you've not subscribed to our channel. Trigonometry deals with the relationships between sides and angles of triangles. And now in this video we shall focus on two types of triangles: right-angled triangle and then non-right-angled triangle. For the case, whenever you hear a right-angled triangle, that means that one of its three angles is 90 degrees. But for the case of non-right-angled triangle, those triangles cannot have angle 90 degrees. Right angle means angle 90 degrees. Now, when we are finding the length of sides of a right-angled triangle and even its angles, we always use SOHCAHTOA, which most of you know as sine is equal to opposite over hypotenuse, then cosine is equal to adjacent over hypotenuse, and then tangent is equal to opposite over adjacent. Find angles and length of sides of a right-angled triangle. But if at all you come across triangles which are not right-angled or non-right-angled triangles, to find its angles, to find its angle and even the length of the sides, you cannot use SOHCAHTOA. Instead, use what we call sine rule and cosine rule. So trigonometry is very important, and it is applied in engineering, surveying, navigation, and astronomy. So this is a very important topic in our day-to-day life. We have here a surveyor is tasked in determining the height of a building in a new development area. From a certain point on the ground, the angle of elevation to the top of the building is 60 degrees. As the surveyor moves 50 meters towards the building, the angle of elevation becomes 75 degrees, and the surveyor must calculate the height of the building to ensure the compliance with the local regulations, which stipulate that the height of a normal building should not exceed 165 meters. We have here our task saying, will the building comply with the local regulations? Justify your response. Now here, whenever we are looking at angle of elevation and angle of depression, the angle of elevation is an angle formed by the horizontal line of sight. This is horizontal line of sight, horizontal line of sight, horizontal line of sight, and observer's line of sight. So this is an angle. So it is formed. The observer's line of sight is always above the horizontal line of sight, and this is an angle. This is an angle of elevation. Let me call it theta 1. So when teacher Isaac is standing here, let me say in front of the tree, in front of the tree, on a horizontal, on a level ground, and here there is a bird on top of the tree. Teacher Isaac can only see here before adjusting his side. If he wants to see a bird on top of the tree, now we will need to trace his side through this angle. That angle through which Isaac sees the bird, or that angle at which teacher Isaac sees the bird on top of the tree, which is above his head, is what we call angle of elevation. And for the case of angle of depression, you'll need to come here and ask yourself, teacher Isaac cannot see a stone which is below his head. Assume a stone is here. Let me put here a stone. So teacher Isaac won't be able. This is elevation. And then I want to show you angle of depression. Teacher Isaac cannot be able to see this stone when teacher Isaac has not lowered his sight. Instead, he will lower his sight until he is able to see a stone which is below his head. So this angle at which we see something below our head is what we call angle of depression. So this is the diagram showing angle of elevation, and then the one showing depression is like this. This is the horizontal line of sight, then I have to lower my sight like this. So this is what we call angle of depression. So in case you are told the angle of depression is formed below the horizontal line of sight, and then angle of elevation is formed above the horizontal line of sight with observer's line of sight. Now we can start. Observer's line of sight. Now here we have our task. I'm seeing here from a certain point on the ground, the angle of elevation to the top of a building is 60 degrees. If at all I have here my building, this is the building. This is our building, and then on the ground, I'm seeing the first point. Assume this is point P. The angle is 60 degrees. 60 degrees. But when he moves 50 meters towards the building, now assume 50 meters are here. From P to Q, these are 50 meters. The angle he can now see the top of the building at an angle of 75 degrees. And I'll ask myself, what is the distance between the base of the building and the first position, which was P? If I told the distance from the second position, the base of the building here is X. Assume I create here A, and then here, the top of the building I put there C. It means that this distance from A to P will be X, will be 50 as X, then here meters. Now, after drawing this triangle, this sketch, you can see now this is the height of the building. Here is the height of the building, which is AC. AC is the height of the building. Height of the building. But now after that, you'll need to extract right-angled triangles. Here I'm seeing three triangles, but not all three triangles will work. We only use SOHCAHTOA We only use SOHCAHTOA to find length of sides and angles of only a right-angled triangle. Because here we have sine theta is equal to opposite over hypotenuse, then tan theta is equal to opposite over adjacent, and then cos theta is equal to adjacent over hypotenuse. So whenever you see these, we have S represents sine, we have cos representing cosine, and then T stands for tangent. So now after having that, you come now and extract the two right-angled triangles that you can use. When, if at all you're not seeing a right-angled triangle, please don't go ahead and use SOHCAHTOA. We only use SOHCAHTOA if at all we have right-angled triangles. Now I have this, you have to make sure that one of its angles should be 90 degrees. So I have triangle A to C, A to C, A to C. So I have A, Q, and C. Also, I have another bigger triangle, which is A, P, and C. But here you can see that HU, I have the base as X. Then here I have the height, let me call it H, C. And also here the angle is 75 degrees. Then this A, E, and C. Of course, this is also angle 90. AP measures 50 plus X, then bracket meters. That is the base. Maybe I'll make it clear. The base is 50, then plus X meters. And then here the H still remains H. And then an angle is 60 degrees. Now, I would like to know, how can I find the value of H here? As long as I have opposite and adjacent, then it's better I use tan. So here, from the first triangle, from this triangle, I'll come here and say that from the first triangle, I'll come here and say that tan 75 degrees is equal to tan 75 is equal to opposite over adjacent. But our opposite is H, and then our adjacent is X. So here I'll make sure that I cross multiply and then I get the value of H. So here H is equal to X and 75 degrees. Then also here we shall come and we say that tan 60 is equal to H out of 50 then plus X. Because here this is the opposite H and then adjacent is 50 plus X. So here we shall now still cross multiply. And when I cross multiply here we get 50 plus X. Then here we shall have 50 plus X. Then tan 60 is equal to H. But here it is better. It is better here you now open the brackets. It means that here our H will be 50 and 60 plus X and 60. Maybe here maybe here maybe I'll come and I say that h, let me come and I say h is equal to 50 and 60 plus x and 60. Now, after having the two values of h, but it is here the two triangles HUC and triangle APC have the same height. Now, what I'm going to do, I'm going to equate the two values of h, because the height for the first triangle is AC, and also the height of the second triangle still is AC. So it means that the two values of h are the same. So now, allow me to take off this. So I'll just come here. I'll come here now. I'll come here and equate the two values of h. Equate the values of h. So here we shall come and we say that x and 75 is equal to 50 and 60 plus x and 60. So it's better now you collect like terms. Here I'm seeing x and also here I'm seeing x. So here we shall have x times 75 minus x and 60 is equal to 50 and 60. But I'm seeing common factor. I have here, I'm seeing here x, I'm also seeing here x. So when it comes here to factorization, I'll have here x into x into and 75 minus and 60 then is equal to 50 and 60. Now to make x the subject of the formula, I'll come here and I say divided by and 75 minus tan 60. Even I come this side divided by tan 75 minus and 60 in brackets. So here we have our x as the value of x as 50 times 60 divided by tan 75 minus tan 60. So here we have the value of x as, I have x as 43.301. Our x here is 43.301 meters. But remember, we are not told to find the value of x. You just come and ask yourself, they wanted the height of the building. Allow me now come and find the value of the building from here. H, you can, after getting the value of x, it's better you substitute that value in x in the value of h. But remember, h is equal to x and 75 degrees. But now I have x. It means that h is equal to 43.301, then here and 75. Then here we get our h as 161.603 meters. And remember here the question was, This is very interesting. The question was, would the building comply with the local regulations? Yes, because the height is 161.603, which does not exceed. Now, this is a very powerful statement. Make sure that you, before responding to the task, first know what are you going to respond to. So here they were saying, if at all the building, a normal building should have a normal building should have a height which does not exceed 168 meters. And here you can see that we have 161.603. Means that this height is below 165 and the building will comply with the local regulations. So that is the conclusion that we can give, because the height is less than 165 meters. So that's how we'd go about that item. So you have to master very well extracting the information from the scenario. So this was the answer as 161.603. You can see that this is a non-right angled triangle, and then this is vertex A, this is angle A, and then here we have angle B, and then here I have angle C. So here we cannot use SOHCAHTOA because this is a non-right angled triangle. Whenever you are given such triangle, especially you can now form this triangle when like in numbers like for bearing. So what you do, use what we call sine rule, because sine rule is used when we are finding length of sides and angles of a non-right angled triangle. And sine rule states that A out of sine A, whereby A is the side opposite angle A, opposite angle A, opposite angle A. Then C, small c, the side opposite angle C. And then small b, the side opposite angle B. Similarly, some people also write it like this. Also, people write it like this. You can also write it this way, that sine A out of A is equal to sine B out of B is equal to sine C out of C, whereby these small letters represent the sides opposite those angles. Again, you see here that the side opposite angle A is this one, and that's why you are seeing small a. Even we have here the side opposite angle B is this side AC, and that's why you are seeing me having small b. And then the side opposite angle C is AB, which is now A, which is now C. So whenever you see those small letters, A represents side opposite angle A, B represents side opposite angle B, and then C represents angle opposite angle C. So that's how else we can write it. But now, when do we use sine rule? Sine rule is used when you are given two angles. We use sine rule when you are given two angles and one side. Because you see here, if I have angle A, assume I have here my formula as sine A divided by A is equal to sine B divided by B. find if I have two angles, like I have angle A and angle B, and I have one side, let me say A, I can be able to find side B. And also one side, then I can use sine rule when I have two sides and non-included angle. So here, if at all I have two given sides A and B, and also I have one angle. So when I have two sides and one angle, I can be able to find another angle. So that's how we use our sine rule. We use sine rule when we are having two sides and one angle, and then all two angles and then one side. So here it's very, 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 very important when we come to this. Then for the case of cosine rule, it states that a squared is equal to b squared plus c squared, then minus 2ab. A squared minus a squared is equal to b squared plus c squared minus 2bc cos a. If at all this is an right angled triangle, I have A, I have B, I have C. The side opposite angle C is small c, the side opposite angle A is small a, and the side opposite angle B is small b. So when we are having sides like B and C, and even an angle between them, I can be able now to find this side A. Whenever you are finding side A or small a, you have to use angle A, because you see here it is a squared is equal to b squared plus c squared minus 2bc cos a. When you start with a squared, use angle A. When we start with B, I use angle B. When I start with C, I also use angle C. And we only use cosine rule if at all I have two sides and included the angle known. And for the case of here, three sides, when you are given other three sides, for example 1 says that in a triangle ABC, angle C is equal to 107 degrees. Then I have also here an angle B is equal to 26 degrees. And line AC or side AC is equal to 15 centimeters. Find the length of AB and then BC. So the first step is to draw a triangle. So this is going to be our triangle like this. This is our A, and this is our B, and I have C. Our angle B is equal to 26 degrees. Then angle C is 107 degrees, and side AC is 15 centimeters. Side AC is 15 centimeters. So now here they are asking us line AB, line side AB, that is our task, and also side BC. Ask yourself, what do you have? I have two angles and then one what? One angle and then one side. And we can only use sine rule if at all I have two sides and one angle to find another angle. All having two angles and one side, then you can use your sine rule. But please, people, I can be able to find this angle A because here angle A is equal to the interior angle sum of a triangle is equal to 180 degrees. So it means that here, to get angle A, I'll get 180 degrees minus the sum of angle C and angle A. And here we shall have 107, then plus 107 degrees, then plus 26 degrees. It means that here angle A is equal to 180 degrees minus 133 degrees. And here the value of angle A will be the value of angle A is 47 degrees. Now that means that here I will be having 47 degrees. Now I'll come here and I ask myself, how can I now find the length of side AB? First of all, where is the side opposite angle A? It is BC, which is small a. And then where is the side opposite angle B? Here it is small b. And where is the side opposite angle C? It is AB, which is now small c. So whenever we come here, we shall come and we say that here we can come and we have this, that sine, we shall have and we say that sine C divided by small c is equal to side B divided by small b. And I have angle C as 107, so here we shall come and we say it is sine 107 degrees divided by, what is small c? I don't have it. And remember, it is side AB. Then is equal to sine B, which is sine 26 degrees, then divided by sine 26, and then here we shall have our small b, which is 15 centimeters. So here we shall come and we say that, how can I find the value of C? So here you always know this cross multiplication. So we shall come and we say that this will be 15 times sine 107 is equal to C times sine 26. So here we shall get 15 sine 107 is equal to C sine 26. Here you can divide sine 26 on both sides to make C the subject of the formula. Here sine 26. And then here we shall have our C is equal to our C is equal to 32.7 to 32.7 2, then here 2 centimeters. So that is C, but we are not asking us to find small c, but remember small c is same as side AB, so we shall say that our AB is equal to 32.723. So this is our side B. And also here we want to find side BC. Where is side BC? We have here BC same as small a. So it means that I should have angle A in my formula. So I'll come here and I say that sine A out of small a, side A out of small a is equal to, here still we can use sine B out of small b. First of all, I have my angle A as sine 47, then divided by small a, which I don't have, is equal to here we have sine B, which is sine 26, then divided by 15 centimeters. So here we can cross multiply. Yes, better we cross multiply. And here we shall have 15 sine 47 is equal to a sine 26. So then after here, you can divide on both the sides. Here you divide sine 26 on both the sides, and even you come this side, divide sine 26. Sine 26. And then here we shall have the answer as the answer here, the value of A, allow me write it here, A is equal to 25.025. Then here we shall say that A is equal to 25.025 centimeters. Allow me take off this one here. Take off this one here. Maybe allow me write it here. So here we shall have A is equal to 25.025. But remember A has been BC. So here I conclude by saying that BC is equal to 25.025, and here centimeters. Also include the units. Example 2 here says that 2 wires support a telephone pole on either side, making angles of 57 degrees and 68 degrees with ground. If the distance between the feet of the wire is 23 meters, find the length of the wire. Assume this is my electric pole, my telephone pole, and then this is the ground. And remember also here, this is the first angle, the first wire. This is wire 1. And also I have the second wire, which is making an angle of 68 degrees with the ground. Assume here I call A, here I have B, then we also have here C. And remember, for more information, they're saying that the distance between the feet of the two wires is 23 meters. From the scenario, the distance between the feet of the wires is 23 meters. They are saying find the length of the wires, but you have to know that this is angle 90, and I'll come here and I ask myself that if here I have angle 90 and then here 57, which angle do I have here? Remember, a right angled triangle, all interior angles of a triangle add up to 180 degrees. Also, for this triangle here, I need also to find what is angle C. But before, I'm seeing here two right angled triangles. The one that this first wire makes with the pole, and also another one that the first wire also makes with the pole. So if at all, this is angle 57, and then angle 90 plus this angle, you should be getting 180 degrees. Also here, 68 plus 90 should be getting 180 degrees. So here we shall come and we say, how can I find angle C? How can I? So I shall find angle C as angle A plus angle B plus angle C is equal to 180 degrees. That means that here we shall have angle A as 68 degrees, then plus 57 degrees is equal to 57 degrees, 7 degrees. Then here plus angle C is equal to 180 degrees. So we shall have angle C is equal to 180 degrees minus the sum of 68 degrees then plus 57 degrees. So here we shall have our answer as I'll have our answer as 55 degrees. Shall have angle C as 55 degrees. Now, what is the new triangle that we have to extract from this? This is our new triangle. This is A as 68 degrees. And this is side angle B as 57 degrees. Then I have angle C as 55 degrees. I have here 23 meters. And then I don't have this side A, which is for the first wire. And also here another side B, which is for the second wire. This is wire 2. This is wire 2. So here, how can I find the length of the first wire, which is BC now? Here we shall come and we say that now that I need A, I'll need now to use angle A. So we shall come here and we say that sine A divided by small a is equal to sine C divided by small c. Because I have angle A, I don't have side A. I have angle C and I have also small c. So we shall come and we say that here that sine 68 divided by small a is equal to sine c, which is sine 55, divided by small c, which is 23. Then from here I've said that you can cross multiply. 23 times sine 68, 23 sine 68 is equal to a sine 55. Now to make a the subject, I'll divide by sine 55, and even I come this side, divide by sine 55. So we get here our a is equal to 23 sine 68 divided by sine 55. And here we have our a as, here we have the answer as 26.033 in here meters. So it means that the first wire, length of the first wire A, BC is equal to 26.033 meters. So it means that the first wire that makes an angle of 57 with the ground is 26.033 meters. That is the length of the first wire. Also, allow me take off this so to find the length of the second wire. The length of the second wire. Also here we want to find small b. Here we shall come and we say, now that I want to find small b, I should include their angle b. So we shall have and we say that sine b divided by small b is equal to, choose any, sine c divided by small c. I have angle b as 57, so we shall have sine 57 divided by small b, which I don't know, is equal to sine 55 divided by 23. And then here we shall have, it's better we cross multiply here. We shall have 23 sine 57 is equal to b sine 55. Finally, to make b the subject, it's better you divide sine 55, and then you come this side and divide sine 55. It means that b is equal to 23 sine 55, then divided by 23 sine 57 divided by sine 55. 23 sine 55 sine 57, then divided by sine 55. And the answer here, the value of b is equal to, 23.548. 23.548 meters. So it means that this side AC is equal to 23.548 meters. So that is the length of the second wire. That makes an angle of 68 or 68 degrees with the ground. So that's how we can use sine rule from our scenario. And also we have here another example about cosine rule. First of all, they are saying that here we have our triangle. Here we have A, then here I have B, and even here I have C. They are saying that angle A is 58.3 degrees. Then small b, which is now 11 meters. Small b is the side opposite angle B. And then small c is 8.5 meters. Whenever we are talking of small c, that should be the side opposite angle C. So now when you see this here, you can see that we have the two sides. We have side AC and side AB with an angle between them. So that the moment you see that, you have to use the cosine rule. And now this will be our A, this will be our C, and then this is our B. Now that I need to find the value of this A, I should use angle A. And here we shall come and state it. Shall come and state it as A squared is equal to B squared plus C squared minus 2BC, then here cos A. I have B, I have C, and also I have angle A. So I can be able to find the value of A. So I shall have A squared is equal to B squared, which is 11 squared, plus C squared, which is 8.5 squared, minus 2 times 11 times 8.5, and here cos 58.3. Here we shall have A squared is equal to 121 plus 8.5 squared, which is 72.25, minus then minus 187, then cos 58.3. So here we shall have our A squared is equal to A squared is equal to 193.25, then minus 187, then cos 58.3. So when I press here the calc once, here we shall have the answer as I have A squared is equal to 94.98686, then here 8. Now to find the value of A, it's better introduce the square root symbol on both sides. So here we shall have our A is equal to 9.746, then here meters. But our A is side BC, so I shall say BC is equal to 9.746, then here meters. Here we have our second example about cosine rule. They are saying that Smith observed the boat sailing out to the sea from the bank in direction of 75 degrees for 800 meters towards 75 degrees for 800 meters towards B. Then changed the course and moved in opposite direction of 285 for 500 meters until it stopped before reaching point C. So help the surveyor to determine the distance the boat will cover if it were to move directly from A then to C. So when you read this item or this scenario, it is all about bearing. But still, I can do it when I have not drawn an accurate diagram. Maybe I can first draw here a sketch, and you can see that here they are saying that here number 1, that this is the town A. 1 moves in the direction of 75 degrees for 800 meters to B. Bearing is measured from north. Then this is my 75 degrees. 75 degrees, but there must be 3 digits. And here 800 meters. But here they are saying, and then this is town B, they are saying that from B now to C, he moves on a bearing of 285. But whenever they say bearing, we must measure from north. So this is 90, this is 180, and then this is 70. Now I need more 15. So now this can be our angle here. So this is our C. Now this bearing is 285 degrees. 285 degrees, and the distance is 500 meters. But now we have here alternating angles. This is angle 75. If at all this is angle 75, also here this part should be angle 75 degrees. Alternating angles. If I can show you here, this is, I'm seeing something like this. If this is 75 degrees, also here I should have 75 degrees. And now out of 75 here I will remain with 15 degrees to make 90, and also here more 15 degrees. So the whole of this give me 30 degrees. So allow me to take off that. So it means that here we shall have 75 degrees. So this angle here will be 30 degrees because this is 75. Then here in the third quadrant, if I deduct 75, I'll remain with 15 and more 15 to come up with 30 degrees. So this will be our new triangle. The triangle will be like this. This is A. The new triangle will be like this. The new triangle will be like this. Shall have here this is A, B, and then here shall have C. This is 500 meters, and then we have 800 meters, and then an angle between those two angles, those two sides, is 30 degrees. So for this case, I'll just come here and I say that now that I have two angles and then one side in between them, I can use cosine rule. And cosine rule, now this is small a, maybe I can start. 500 is small a, this is small a, then this is small c, and then this is small b. But now that I want distance between a and c, I'm going to use angle b. And how do I state that that cosine rule? I'll state like this: b squared is equal to b squared plus c squared minus 2ac. Then here cos b. I told you when you use side b, you have to use angle b. But I don't have side b, so I'll come and I say what is a? 500 squared plus 800 squared minus 2 times 500 times 800, then here cos 30. Then here we shall have b squared is equal to, if I press this once in the calc, here we'll get the answer as 197 197 197 197 179.677. So to get the value of b here, you introduce the square root symbol on both sides. So when I introduce the square root symbol on both sides, we shall have b is equal to the square root symbol. We shall have 444.049, then here meters. So it means that the distance from A to C is equal to 444.049 meters. So that is cosine rule. For those who drew an accurate diagram, they were getting 450 meters. But here we can use also cosine rule to find the distance between 2 points, even in bearing. As long as you form a right triangle, you know where to put those sides, you can still use cosine rule. So here we shall come and say that sine rule is best for the angles and opposite sides. Then cosine rule still is the best for sides and included angles. Then applications in navigation, surveying, engineering, astronomy, in physics, then mathematics connects the theory with real life problem solving. Real life solving. Thank you so much for watching. We meet in the next session.